This is the first equation we have learned in class to calculate the entropy change during a process. It is also the thermodynamic definition of the entropy change. Q reversible represents the heat of a reversible process. Q reversible has the same unit as energy. Joule and kilojoule are the two most commonly used units for Q reversible. T represents the temperature at which the reversible process occurs. The unit of T can only be Kelvin. You cannot use degrees Celsius or Fahrenheit as a unit of T when you use equation 1. Let me use an example to illustrate how to use equation 1 to calculate the entropy change during a process. As we always do, we will follow a 3-step procedure to try to find a solution for any given problem. Summarize, analyze, and work out the details. First, we will read the problem from the beginning and write down the most important information. There are 3 kinds of information we consider as important information. If you have a chemical reaction, a balanced chemical equation is the important information. Numbers with units is another kind of important information. What we are looking for is the 3rd type of important information. Let's start from the beginning. What is the entropy change, delta S, for the melting of 3.48 gram ethanol at negative 114.1 degrees Celsius and 1 atmospheric pressure? As you may have already noticed, I assign a symbol to every number of its unit. This will help us to identify what equation we need to use because all equations contain symbols, not numbers. Let's continue. The standard entropy of furan is 4.9 kilojoule per mole, and the normal melting point of ethanol is negative 114.1 degrees Celsius. We already write down the temperature, so I'm not going to write down the temperature again. Next, we will conduct some analysis. During this step, we will try to find any hidden information, and also we want to find out what kind of calculations we need in order to find a solution for our problem. Sometimes you need to read the problem again. When we read, the normal melting point of ethanol is negative 114.1 degrees Celsius. Normal means the pressure is 1 atmospheric pressure. This tells us that the melting of ethanol at this temperature and pressure is a reversible process. This is from what we have learned in class. The melting at the melting point is a reversible process. Then, if we want to use equation number 1 to calculate the entropy change, we want to know what kind of information we already know and what information we need to find. I copied down the equation. This will help me to memorize the equation. If I work out more and more problems every time I write down the equation, I will automatically remember the equation. If we want to use equation 1 to calculate the entropy change, we need to know the temperature in Kelvin. From what we already know, we know the temperature in degrees Celsius. If we can convert degrees Celsius to Kelvin and we know Q reversible, then we will know we can use equation 1 to calculate the entropy change. Let's see if we know Q reversible. Q reversible is also heat. Remember, we have learned 5 equations to calculate the heat during a physical process. These are the 5 equations we have learned earlier. For equation 4 and equation 5, they can be used to calculate the heat during a phase transition only process. The melting at the melting point is a phase transition, and there's no temperature change during this process. Therefore, we need to use equation number 4 or equation number 5. The standard enthalpy of fusion is provided as kilojoule per mole. Therefore, we need to use equation number 4 to calculate. Again, I copied on this equation because it will help me to memorize the equation. From our analysis, this Q is also Q reversible. This delta H is already given. We do not know the moles of ethanol, but we do know the mass of ethanol. We learned that if we know the molar mass of ethanol, we can convert the gram to moles. And we also know the formula of ethanol. If we know the formula of the ethanol, we can convert to the molar mass, or we can calculate the molar mass of ethanol. Well, from our analysis, it seems this problem is doable. This is the first step, and this is the second step, and this is the third step. This is the fourth step, and we plug in Q reversible and the temperature. We can calculate the entropy change. This is our last step. Now let me show you the details of all steps. Step 1. We will convert the temperature from degrees Celsius to Kelvin. We punch both numbers into a calculator. We get 159.1 Kelvin. Step 2. We will calculate the molar mass of ethanol. We have 2 carbon atoms in 1 molecule of ethanol. For each carbon, it is 12.01 from the periodic table, and we have 2 carbon. For each hydrogen, it's 1.008 from the periodic table. And we have 3 plus 2 plus 1 equals 6 hydrogen. We have 1 oxygen is 16.00. We punch all numbers into a calculator, we get 46.068. And the unit for molar mass is gram per mole. Step 3. We will convert the mass to moles. After our calculation, we get 0.0755 moles of ethanol. Step 4. We will calculate Q reversible. The heat is 0.370 kilojoules. Step 5. We will calculate the entropy change. You can also convert the entropy change to joule per Kelvin. It is up to you whether you want to convert or not, because the question did not ask us in any particular unit. I want to emphasize this part is not required for an exam or a quiz, but it is very important for you to be able to conduct analysis, because when you're given problems, it can be very different in terms of the way it's presented to you. But after your analysis, it will become the same. And this part is what I need for an exam.